brought back, I went to the sawmill, got the sawdust. When I mixed this discharge of the tannery with sawdust, I could generate a wood which is so strong, it will never be, like I told you, what properties it would have, the strength of it, and infestation, free from infestation, and other things. Other thing, he started narrating that I have a solution to the world's energy problem. And I want to patent it very fast, because if Western world come to know about the solution I am proposing, I may be killed, because if India becomes supreme in providing free energy, then the whole India will become superpower, which the rest of the world may not like to do it. Be that. So what I said, what is that? Please let me know. I am very curious to know what is the world's energy problem that you have, solution to the energy problem. So basically, what concept he was giving us was, he told us, free energy for the world, that is, that there is a gravity which pulls the object down. Isaac Newton, I remembered Isaac Newton giving the concept of gravity. So there is a mass and density of the object which attracts towards down, and there is a buoyancy. So, which is the density of the fluid which is going in the opposite direction. So he says, like ship, we have the center of buoyancy and center of gravity. If they are in the same line, the ship floats. But if the center of gravity varies and the center of buoyancy, they are in different direction, the ship may not be as stable and may get inclined, or it may dip more if the center of buoyancy and center of gravity are not positioned equally. So what he said was, what I've done, simply creating a system where gravity pulls my object down and buoyancy pushes it up. And then I have a system which goes up and down, up and down, up and down, up and down, free of any input of energy, using simply the nature's phenomena of gravity and buoyancy. But he says, yes, I need water and gravity and something which really helps me to. So I said that in our villages, we have to draw water from wells using the bullocks. And you come to my village, I will show you that there is no bullock needed to draw water from the well in my village. I have the system which is working 24 hours a day without any energy input. I said, it's so surprising. Then everybody should be using it. He said, I have not disclosed this to anyone else till I am able to patent it. So he was requesting my father that you're working in Punjab University, why don't you get me connected to someone in science and who is a prolific patent he's into the process of patenting. Now, of course, we guided him to someone else who was from science and was into patents. But the concept which I then later found out was, and I Googled search that anyone else knows about it, and I found that there's free energy, searching for free energy and discussing free energy. This was on the website, underwater wheel. So what they say is that you have a filled water and you have a rotation. So you have a ball and you have this pocket. Your ball comes, it goes into the center of the pocket, takes it down, and then you have a PVC pipes connected over here, and it gets filled. And when it gets filled, the water, when the ball comes down, it goes into the PVC pipe. And this way you can have a free energy, weight and bag, weight and bag, weight and bag. So this way it will continuously rotate. So what I want to say is, through this example, One thing is that a simple commoner, a farmer, had a sense of looking into nature and finding out some new inventions or inventing something. It is a thought process which came to his mind. We people, when we are discovering and researching things in our lab, we are very, very less innovative at times because we only do invention through experimentation. Yes, he also did, but we simply don't look into nature and understand nature and try to have focused inventions looking into the nature. But what I want to say is through this example of what I found on Google and what he told me several years ago, that in science, make sure I'm reading it so that you are very clear on it. One has to be sure that a translation idea which has come to my mind or your mind at any stage of time is not exclusive to you. It can, the same idea can come in somebody else's mind, and you have to be quick in its protection. So otherwise you lose that chance. The third example I want to give it, although it's not truly translational, but it has, it doesn't lead to a product, but it has its own, I will say, good aspect to it. That is into the insight into the fire walking while at Punjab University, when I was working at Punjab University as a faculty member or earlier as a student, because my all education, B.Pharm, M.Pharm, PhD had happened at University Institute of Farm Sciences at Punjab University. And I had a huge habit of sitting in the library, looking into magazines, journals, books, and my free time, lot of it used to be spent in library. And Punjab University has a very good multi-story library. So I was going through one of the magazines, which is Scientific American, and it was in 1976, although it was later, one of the article of this under this title was published in 1977 also. It talks of drops of water dance on a hot skillet and the experiment walks on hot coals. That is Leyden frost phenomena. So this article I was attracted to, and I read through the whole article that what way they are explaining the scientific phenomena behind fire walking. And they explained through the concept of the phenomena known as Leyden frost phenomena, how a person is able to walk on hot coals. Now, later also in 2012, there I found a similar article, Come Fire Walk With Me, The Physics of Hot Coals. There is a professor in US, physics professor in US, who selects PhD students, and his admission test is that if you really believe in physics and you want to be my student, you have to walk on hot coals, and this is your admission test. Think over, if I ask my Indian students, you have to really walk on the hot coals, and then I will only admit you. You will be protesting outside the college. Hey, what it is. But what was the motivation for this physics professor in US to put an admission test of such a harsh kind? Because I said anybody who has to be my student has to believe in a physical phenomena, physics phenomena behind an observation. So that is what his logic had been, that a student must believe that there is physics behind the phenomenon which allows a person to easily walk on red embers against when the same act is repeated on a red hot metal surface. You cannot walk on hot metal surface, but you can walk on red embers. And what explanation was provided was that a layer of moisture is created immediately when you are putting your feet on the hot coal, because there are gaps. So that moisture immediately again evaporates because of the heat below, and then it gives a cooling effect and you are able to walk on red embers. Now, in India, fire walking is shrouded with a mystical uh, mystery and spirituality. It's a ritual that a person is walking on call, and they say that this person has a super high spiritual powers, and that's why he is able to walk on the red embers. I there was a discussion which got started and found that there was an article at that time in 1985, in somewhere there was in July 1985 issue of Illustrated Weekly of India. Khushwant Singh was the editor of this journal at that time, magazine Illustrated Weekly of India. And there was a article like I have written over here. This was the letters to the editor I wrote, Saranjit Singh from Chandigarh. I wrote in Illustrated Weekly of India. It was easily accepted by Mr. Khushwant Singh. So it says there was a discussion that had gone in July 21, the mysteries of science. Senal, this person in a rejoinder, Hawks, September 1 to Mukul Sharma, the mystery of science, rightly says that a firework is no miracle or mystery. This is what I am writing. The fascinating and mysterious fireworking phenomena is related, see Scientific American 1976, page 120, to a very elementary rule of physics, established far back in 17th century, which is known as Leidenfrost effect. Applies to all examples where wet skin suffers no harm on touching hot material. The remarkable protection against high heat is provided by a thin layer of water coming through the initial wetting of the natural moisture in the skin. So we have written over here why it can be metal surface, because metal surface it will be a totally covering your skin and it will not allow moisture to escape. That's why you are unable to do it. And there was a lot of challenge by all these miracle people and who believe in miracles. And they said that Baba, Shri Saptarishi Balti Baba, I would like to show that Saptarishi Balti Baba has with play accepted the challenge as a representative of all the saints and sadhus in India, of India under the following conditions. So this was a very interesting exchange of thought process with respect to, on one side you have all the sadhus and rishi, and other sides we have the scientists. So it was really, although it was not basically related to my field, but it really gave me a lot of strength to really believe in science. Again, I am facing that same problem. Vivek, can you help me that why I'm getting those messages of waiting room? Now, this what I want to convey to you all is that scientists and rationalists think differently and look into logic behind any phenomenon. You people also, maybe in your villages, because I can know SNJB is located remotely. When I have traveled, it is 65 kilometers away from Nasik and on a highway and surrounded by villages. So question comes over here is lot of these people or persons or saints and sadhus coming to your localities and your areas to say that we have super spiritual powers and other things and we do this, that. But you as scientists and rationalists, you have to think differently and look into what is the scientific phenomena behind what these people are doing. So this is my request to you all. Now, when I came to Naipur and started teaching after my 13-year stint at Punjab University, so I was again exposed to some new concepts, which I will talk one by one, 4 of them, 4.1. Replacement of Parajan test by BT test. Now, you know that Indian Pharmacopoeia was the first to introduce the BET test. Earlier, we used to do Parajan testing for parenterals. And this has been always done on rabbits. Many of we people, we have done this experiment during bee farm, recording the temperature, rectal temperature of rabbits to the huge inconvenience. These rabbits have to be restrained, and then we have to take their temperature to check out presence of pyrogens. Now, the new in vitro test is bacterial endotoxin test. Again, I am very proud being a scientific committee member at one time of Indian Pharmacopoeia Commission that IP was the first to introduce this test among the world compendia. Now, what is the origin of this test? We have to again go back to the nature. At one time, lot of horseshoe crabs were found. They washed the sea and came offshore. And you can see this picture, how these horseshoe crabs are found dead on the seashore, on the beach. And the scientists are puzzled what has happened. They wanted to study. They took all horseshoe crabs to the lab. And they found that there was infection of gram-negative bacteria which has killed them. And when they more deeply investigated, they found that their blood, the horseshoe crab blood, has been all clotted. So they found some link between the gram-negative bacteria infection and clotting of the horseshoe blood. So from there, they thought the concept that it means that gram-negative bacteria, if it leads to clotting of the blood of horseshoe crab, and they reported in the journals, other set of scientists pick up that report and develop the BET test, that is bacterial endotoxin test. So now what we are doing is we are collecting the horseshoe crab blood, which is blue in color, in our labs. Of course, this is torturous for the horseshoe crab. We have moved away from rabbit. Now we are having in vitro test, of course, but again, we are withdrawing blood from the horseshoe crab in the lab. So this has, we take lysate from this and exposed to bacterial endotoxin test through what we say, we take, if there is a gram-negative bacteria, metabolites, or otherwise constituents present in our any of the injectable parentals, it will show clotting factor, and you will see that there is a gel created if we take this lysate. So question comes over here is again a natural phenomena occurring, that somebody found horseshoe crab in thousands which have died and washed off the sea into the beach. And these were collected. Somebody reported the reason for their death and clotting behavior, and some other team picked up idea to develop a test. So this BET test has an origin to a happening in nature of horseshoe crabs dying due to bacterial infection. Now what is happening? I was able to see this in PLOS Biology in 2018, saving the horseshoe crab, a synthetic alternative to horseshoe crab blood for endotoxin detection. So this is how science progresses. And basically, the behind phenomena is all observation that has happened in nature. Second is interesting, the tree hello story. Now, what is tree hello story by Insight? There were scientists which are roaming in deserts. You can see a scientist doing some seismic activity monitoring or something in the desert area. And you can see it's a deep summer. You can see the shadow of the person. And everything you see, vegetation is dried up due to 50 degrees centigrade temperature. This person has a hat on the top of his, and they are roaming around in the desert. So a similar kind of team was roaming in the desert. This picture I've just taken from Google Images to just represent what I want to say. So the team was roaming, as the team of scientists was roaming in the desert, and they were just picking up small stem of these shrubs and just will break it. And because they found that everything was dead and it was easy to break any stem of any shrub or whatever it is, you can see over, if I pick up and break this, it will easily get broken and everything is dead. All plant vegetation is dead by look. So while roaming around, it came that there was a rainy season which had come in, because after summer, there is a rainy season. And they were still in the desert area. And very interesting, they found that the same plants which were totally dead sprung into life. Now, a small observation, something which was totally dead, they could pick up a stem and break it easily. Nothing, no life, no leaves, no fresh leaves, nothing, no vegetation of live vegetation. First drop of water and some wetness in the soil leads to outgrowth of leaves and flowers. Something stuck to this team. What had been keeping the life alive in a dead plant which has gone dead due to harsh temperature environment? They collected this material, lot of this material, took it to the lab and tried to find out what sustains life in a dead environment, means dead tissues of plants. So what they found was that these plants, dead plant material, was all rich in trehalose, which has two glucose molecules connected to each other. It means high concentration of sugar even in a dried form was maintaining the life, sustaining the life at very high temperature. From there, you can see the 1st September 1992, Nature Biotechnology, extraordinary stability of enzymes dried in trehalose, simplified molecular biology. What it reads is, the abstract reads is, we show that extremely fragile biomolecules such as DNA restriction modifying enzymes can be dried in vitro in the presence of trehalose with no loss of activity, even after prolonged storage. A remarkable and unexpected property of the dried enzyme preparations is their ability to withstand prolonged exposure to temperature as high as plus 70 degrees. This stability is unique to trehalose and is not found with other sugars, irrespective of their physical or chemical properties. The stabilization of a wide range of biomolecules by trehalose also has practical implications for a number of areas ranging from basic science to healthcare and agriculture to bioelectronics. The whole area of science of stabilization of biomolecules opened up with a small observation of scientists roaming in a desert, how the life is sustained in a dead plant, looking to be dead plant, but first drop of water kindles a life in a dead tissue. So now we are in 2016, you can see the role of trehalose for the stabilization of proteins, published in Journal of Physics and Chemistry. Third example which I want to give is other examples of biomimicry. Now, very interesting. The other day I had birthday in October. So I told my all students that I have prepared one lecture which I want to give it to you all as my birthday gift. And in one evening, the time was set and gave a lecture. One of my students, who is at this moment working as a scientific officer in A-Star Institute in Singapore, last year batch, 2019 batch pass out. She immediately sent a WhatsApp to me. And she said, I was reading a book which gives a similar type of projection of what way you have talked and what examples you have given that look into the nature and look into what discovery you can make. Look into the nature. So she says, and she wrote to me that the term used is in science is biomimicry. Now, that was also a learning for me at this age, near to retirement. The word biomimicry, I was talking to another one of my faculty colleagues yesterday at NIPER, day before at NIPER. He says, I also have heard this word biomimicry first time in my life. Now, she sent me the photograph of the book page where it says biomimicry. it defined that biomimicry. This was the book she was reading, and one of the page defines biomimicry. It says, inspired in part by the Velcro story, analogs and insights. They call the practice biomimicry. Nature, the arc, boasts 3.8 billion years of experience in product design, recycling, sustainability, and complex system. 3.8 billion years of the nature has developed product design, recycling, sustainability, complex system. Why not look there for inspiration and new connections? Indeed, the water repellent properties of lotus leaves have helped engineers develop self-cleaning glass. The communal activity of beehives help business consultants understand organizational behaviors. And a bird beak recently saved Japan's bullet train. So then they are talking of the story of the bullet train. The new train came zooming out of tunnel so far that it created a lot of sound or so whatever it is. So what is the Velcro story? I think all of us has faced these dry fruit or the seeds which have our knickers or our legs, they have stuck to our legs. And Dr. George D. Menstral, who was inventor of Velcro, he looked into that this is a common phenomena that when I am roaming around in a bit jungle area and other things, these things stuck to my pant or to trousers or whatever it is. So I went to engineers. Can we have same type of needles created, which are curved needles created? And eventually they created machine, and there was an invention of Velcro. So it was inspired after 1941 walk in the Alps with his dog, in which he encountered a bunch of burrs. So these are the burrs, which even attached to the hair of the dog and in his trousers. This led to the story of Velcro, or the development of Velcro. So Neil Armstrong showing the Velcro brand from the space station, because all these suits, you can see now you also buy the jacket from the market and it has a lot of Velcro, which helps you in keeping things bound to each other. So again, something from nature that the whole development of Velcro has happened. Now, what was the link between a bullet train and a, let us say, the bird which we are talking about? It says, until the late 1990s, a negative aspect observed in Japan bullet trains was the loud noise they made on exiting the line's many tunnels. Now, if you have this shape, and compare this shape with the lower shape, the front shape, now it is hugely different. Or if it is little bit bullet train which runs at a speed of 300 plus kilometer, if it is blunt, so when a train entered a tunnel, its blunt bullet-shaped nose compressed the air. When the train exited the tunnel, the compressed air expanded so rapidly it produced what is known as a tunnel boom, a loud disruptive noise, which led to people waking up in the surrounding of that tunnel, whosoever from the early sleep, that it was so loud noise. And how it was solved? Just changing the shape, converting the trains to kingfish beak solved the problem entirely. So now you can see same beak design of kingfisher, the trains are built up, modern bullet trains are built up. So very interesting examples that I could collect over the years, including my latest interaction with the students and trying to know about the biomimicry concept. Now, I had an enchanting experience in 2019 where I had a chance and I was invited to a session by a Nobel laureate at Punjab University. So on March 14, 2019, this was a news that had come, but it was on 13th March. And Dr. Fringa, who was awarded Nobel Prize in Chemistry for the design and synthesis of molecular machines in 2016, was speaking at 30th Chandigarh Science Conference held at Punjab University. I was sitting in the next row over here in the front chairs. It was really a treat to listen to him around 1 hour lecture and to understand the whole concept of molecular machines. So it's a molecular machine to revolutionize drug delivery, cure, Nobel laureate. Now, I came back, tried to research the Nobel Prize Committee's website and try to look into more about to understand what he spoke about and why these people were awarded the Nobel Prize. So when I looked into the press release, the Nobel Prize in Chemistry 2016, 5th October 2016, the Royal Swedish Academy of Science had decided to award the Nobel Prize in Chemistry to Jean-Pierre Sauvage from France, Sir Stoddart from USA, and Bernard Elfringa from Netherlands for the design and synthesis of molecular machines. Now, I looked into the whole development by these three scientists who led to Nobel Prize. Now, basically, this Nobel Prize, as I could understand, was for ideation and extension of biological phenomena to chemical molecules. Now, let me see if this video, I'm able to get the video, yes. Now, this is an animation of DNA. Please watch for a few minutes before I close. It's talking of nucleus, a large 10 lakh times, 1 lakh times. Human cell 10,000 times. Your body has 10 trillion cells. So friends, try to understand, let us look into the situation that we all are sitting in front of our laptops or computers, but inside our body, trillion of cells, they are restlessly working 24 hours to keep you alive. Cells are dividing, RNA, DNA replication is happening. The whole body is in a full dynamic state at all the times. Although, if you don't want to raise your finger, it is upon you whether you want to do or not. It may be static for hours together. But finger is static, but inside every cell is on its job to keep you alive. Now, this concept that our whole body is made of motor, it's in motion. What is a motor? It is in motion. If motor is not working, it's not a motor practically. So we have all body into a dynamic state inside. Now the question is, these scientists thought of, can there be chemical motors generated? Can molecules be rotated in situ outside in vitro system? So they developed a mechanism that provided energy, a part of the molecule at a, you can see this bond starts rotating if the energy is provided from externally. Now, this is what they created, a cluster of molecules, taking this molecule, linking them to each other, and they created a molecular motor. And further on, you can have a more complex motor which can keep everything moving, the total system moving. This is almost similar kind of thing what is happening in our body. So what happens? Dr. Fringa was telling that my research student in the morning, that was only that we are thinking theoretically that it can happen when we provide the energy. But he says, my student showed me under the microscope one fine morning, see how the molecules are practically rotating under the microscope. And this video he showed. So when I went to Nobel lectures published in the art of building molecular motors, the art of building small from molecules switches to motors, Nobel lecture. I think all of you really need to read this to understand what Nobel laureate discoveries, why they are awarded. And he created a molecular car. So this is a mesoform and 180 degrees unidirectional rotation, 200 degree again unidirectional rotation. And you can see over here red ones and the white ones, and then both of them have changed the place. So what he created was molecular vehicle in motion. So chemistry Nobel Prize winners use molecules to build tiny machines and cars. Wow. So same thing which is happening in our biological system, they created through chemistry. And this is a molecular chassis, and you have rotating molecular motor, which explains how this really happens. Now, let's look into another video for 2 minutes. The Nobel Prize in Chemistry 2016 molecular machine, same what Dr. Fringa had given the concept. You will really love to listen to it.
Molecular machines. What are they and why are they important? Meet Hannah. She always works hard at her office during the day. Exhausted, Hannah comes home and must wash her clothes and prepare to cook dinner. Cooling off in front of a fan, Hannah considers that 200 years ago, people had to work without these tools. She wonders how they managed it. At the time, scientists had only invented spinning wheels and cranks, which led to the tools Hannah uses in her busy day. But can chores be made even simpler for future generations? For that, scientists must continue to develop tomorrow's machines today. When reading about this year's Nobel Prize winners in chemistry, Hannah discovers that scientists Jean-Pierre Sauvage, Sir J. Fraser Stoddart, and Bernard L. Feringer have taken machines to an entirely new level, the molecular level. They have designed and synthesized machines out of molecules and ions, much tinier than Hannah's food processor. How is it possible to make these machines? Jean-Pierre Sauvage began the development using minuscule molecules to create interlocking parts that can be moved in relation to each other. He used a copper ion to stick together crescent and ring-shaped molecules. Repeating this process, he created a chain of molecules, taking his first step towards a machine with a chain in which one ring rotates around the other. Fraser Stoddart later built an open ring with no electrons and an electrically charged axle. The ring was attracted to the electrons and threaded itself onto the axle. With the ring closed, it jumped between the electron-rich areas of the axle like a tiny ferry. Stoddart has also designed a tiny lift, a muscle, and a super tiny computer chip. Taking it a step further, Feedinger produced the first molecular motor in which a rotor blade spun 180 degrees repeatedly with each UV light pulse. He has even built a four-wheel drive nanocar. The four motors function as wheels and are held together by a molecular frame. Inspired by previous research, artistic expression, and the possibility to create new materials, these scientists brought chemistry to a whole new dimension. Hannah considers this new dimension and its seemingly endless possibilities. Already, other researchers have found ways to store energy with molecular motors or even create a molecular robot that can grasp protein building blocks. With the path now paved, perhaps in another 200 years, Hannah's great-great-great-grandchildren will wonder how she managed to survive without their widespread molecular machines.
So friends, what Dr. Fringa was trying to tell was that you people today who are working, you never knew that there will be a mobile in your hand. Did you ever think of? Did our ancestors, our parents think of that? You cannot think what is going to happen at this moment of the discovery of molecular motion and molecular machines, molecular motors. They are foreseeing endless future of this, like molecular information system, responsive materials, smart surfaces and coating, self-healing materials, delivery system, precision therapeutics, adaptive catalysts, roaming sensors, soft robotics, nanoscale energy converters, and molecular machines. So look into the possible of self-healing system, that your car, you have touched anything and the paint has got scratched, and automatically on the UV light, when it falls on it, when you place it in the sun, it self-heals itself. You don't need to have to go to the painter to reheal itself, because there are molecular molecular motors, and they will now start working on it. Whenever there is an injury to the paint, it will start self-healing. How our body does that? If you got an injury and a cut on your skin, it heals itself. And you cannot see even the scar a few days later or a few weeks later. This is what they are trying to replicate, and they get Nobel Prize due to that, and this leads to endless future. Today, you have a broken glass of your mobile, and you have to go to a mechanic to get it replaced at 3,000 rupees, 2,000 rupees. What if it self-heals? Because of the glass is made of chemicals which can act, the molecular motors, which can really heal itself. Think of what future we are getting with the discovery of these Nobel laureates. So friends, I again prop you up that Nobel Prize award shall not be taken as news. You must dive deeper to understand future impact of each discovery done by Nobel laureates. It will give you a very totally different perspective. Till date in my life, I never looked into really, except that what we are told in childhood, I was never focused on what Nobel discoveries mean to the world. I think my learning at the age of 65 to start looking to one lecture changed my life by Dr. Fringa. It changed my life and the thought process. Of course, I had a lot of examples of discoveries from nature, but this really changed my life understanding that why Nobel laureates are Nobel laureates in real sense, how their discoveries are going to change the whole world. So what is my appeal to you all? Leonardo da Vinci said, where nature finishes producing its own species, man begins with the help of nature to create an infinity of species. Signifying the power of human thought process. So you can make 1,000. Now this mobile is not nature made, but it has lot of all things natural. And human beings are creating those infinitely. And what Albert Einstein said century ago, the true sign of intelligence is not knowledge. We say Google gives us a knowledge at the just touch of a mouse. He says no, true sign of intelligence is not knowledge, but imagination. As a scientist, if you imagine the unimaginable, it may be a mantra of future success and fame. Again, in the words of Dr. Fringa at Punjab University on March 13, 2019, he said, follow your dreams, be confident, discover your energy, your passion, discover your limits, and decide how high you wish to set your bar. So what we human beings, as scientists in India, whether forget you are pharmaceutical scientists, you are part of the whole scientific community. We all have to set up our bar. I want to be the best scientist in the world. I want to be Nobel laureate. I want to be that. Had I listened to Fringa, Dr. Fringa type of Nobel laureate way back in my early days of research career, it may be that I have set my bar very differently. So today, whosoever is listening to this lecture, my wish is that you look into what exactly Dr. Fringa is saying. I repeat, follow your dreams, be confident, discover your energy, your passion, discover your limits, and decide how high you wish to set your bar. So have fun, friends. Look around at nature, keenly and innovate your future. But before I close, I just want to again emphasize on look around at nature keenly and innovate your future. Now you see this, again my student after lecture told me, and I could collect this image from Google Images. All life on earth is made up of 82% plants, 13% bacteria, 5% everything else, and humans make up only 0.01% of Earth's total biomass. So 86% of life is on land, 1% in oceans, and 30% in deep subsurface bacteria. So we are just 0.01%, my friends. 99.99% is nature. So what I said earlier, billions of years, the nature has developed products. Nature has done so much transformation. And I have given a very small list of examples where nature has led to scientists to lead to huge discoveries. So friends, finally, thanks to all. Salute to COVID warriors and COVID winners. Jai Hind.
Thank you, sir.
Thank you, Ji. So nice of you all.
Thank you, sir. Thank you, sir. It was really a very interesting, thought-provoking, and very intriguing session lecture given by Dr. Saranjit Singh, sir, the master himself. I promise, Dr. Saranjit Singh, sir, I am sure that this lecture of yours may have encouraged many young minds to take up, at least to read the Nobel laureates literature. Thank you, sir. May I now invite Dr. Krishna Iyer to sum up the teachings of Dr. Saranjit Singh, sir. Dr. Krishna? Dr. Iyer, sir. Hello? Yeah, I think...
He's setting his system.
Okay.
But Iyer, back to you, please.
Thank you, sir.
From the friend to the friend.
Hello, am I audible now?
Yes.
Yeah. As I said in the outset only, it's always a pleasure to hear Dr. Saranjit Singh talk. And one amazing thing about Dr. Saranjit Singh is none of his talks are the same. So even if you hear him today and then he gives a talk tomorrow, he'll make it different and he'll always add something very interesting. Okay. Now, most of the people here who are in the audience have to realize what you have to look at when Dr. Saranjit Singh is presenting is not only the examples that he is giving, but more importantly, what is the bottom line he's trying to tell you? What he's trying to tell you is how differently you can be an inventor. Okay? You can be an inventor purely by abstract thinking, which is what some people do. But one other way of being very, very inventive is to simply look around you and see how nature does things. And there are a lot of things in nature which can inspire you to be a good scientist and be a good discoverer. Okay? So, what I also want the young scientists to take home from this is that if you are attentive, if you keep your eyes open, if you are constantly taking everything in, which is happening around you, there are so many things around you that will give you ideas to do things in the laboratory. Okay, and it's been a pleasure to listen to Dr. Saranjit Singh and some of his wonderful examples. In fact, I've also made it a habit, maybe because of association with Dr. Saranjit Singh, to follow Nobel lectures and Nobel inventions. In fact, 2 weeks ago, I gave a talk on CRISPR technology. Again, the Nobel for this year. And if you look at what the CRISPR scientists did, that is also so amazing. Looking at nature, now they have invented tools to edit your genome, but the bottom line was how nature did it. Okay, so I advise all the people listening to this is to be inspired and look at nature and do good science. Okay, and thank you very much, sir. Again, a pleasure listening to you.
Thank you.
And I hope, I don't know, Dr. Chatpaliwar, are there any questions in the chat box or anything for Dr. Saranjit Singh? If there is, please take over.
The chat box was, thank you, sir. The chat box has been examined, and we have seen all the WhatsApp and YouTube question as also, but there has been only appreciation for the lecture. There is no question, sir. I think when Dr. Sanjit Singh talks, it makes itself clear. This fact has been well established now, sir. Uh, on behalf of SNJB Pharmacon 2020 organizing team and SSDJ College of Pharmacy, I wholeheartedly thank these two noble people, these two generous people, Dr. Saranjit Singh sir and Dr. Krishna Iyer, who out of their against the situations, against the um, odd situations they are facing, they made themselves available to help us in the conference. Let me quote here that it is the driving force of Dr. Saranjit Singh sir who propelled us, who encouraged us to increase the time span of the conference from 2 days to 4 days. And I really should mention here that I am very much thankful to Dr. Saranjit Singh's encouragement that he provided us, and this has been made possible due to his encouragement, sir. Uh, Dr. C.D. Upasni, he is available here, and he wants to add something to this.
Thank you, Dr. Krishna Iyer, sir, for your presence, and thanks are due to Dr. Saranjit Singh, sir. He is the main driving force for us, and he encourages us for these activities. Initially, we were little bit disheartened that he was not present for the first day inaugural talk, but somehow he could make it. He also have some love and affection towards SNJB and we, the faculty of SNJB. So thank you very much, sir, for your presence, for your informative lecture. I am indeed very happy, and I am looking forward for this association for a long time. Thank you very much. Thank you, sir. Namaste.
Namaste.
Yeah, longing to enough to have you in person here, sir.
Okay.
Thank you all.
Thank you, sir.
Thank you. Thank you, sir.
Dear delegates, dear participants, all the guests of honor, all the speakers available, we take a break from here, a short break though, and we will be meeting after the lunch break at 2 p.m. All the participants are hereby requested to rejoin, log in at 1:55 p.m. Once again, thank you, sir, for your lecture. Once again, thank you, sir, for blessing us with your presence. Thank you.
Thank you. Thank you very much.
Thank
Thank
you.
you.
Thank you.